Anion solution gives a white precipitate with AgNO3 solution. The precipitate dissolves in dilute ammonia due to the formation of, here are the options. Now, an anion solution gives a white precipitate with AgNO3. Therefore, when AgNO3 reacts with chlorine, it gives AgCl, which is a white precipitate, plus NO3 minus. Now, this white precipitate, AgCl, dissolves in dilute ammonia plus 2NH3 due to the formation of diamine silver chloride, which is AgNH3 twice Cl, which is diamine silver chloride. Therefore, the correct answer here is option C. Which of the following is an inner orbital complex as well as diamagnetic in behavior? Here, the atomic number of Zn, Cr, Co, and nickel are given. Here are the different options. Now, apart from the options, we know that the oxidation number of cobalt is equal to plus 3. Therefore, cobalt as an inner orbital complex, which is given by S and P3 are all absent. Now here, so here is the cobalt's energy states. Therefore, we know that it is an inner orbital complex. Now, the answer is option C, which is CO NH3 6 D3, because in here all the electrons are actually paired. So here the sp3 is actually empty, but here all the electrons in the d orbital are paired with their corresponding electrons. Therefore, this is also known as this is also diamagnetic, which forms a spin of d2 sp3. Therefore, the correct answer is option C. Oxidation number of cobalt in KCO4 is, now let the oxidation number of cobalt in this scenario be X. Therefore, the oxidation number of K is 1 plus into plus 1 plus X plus 4 into 0, which is equal to 0. Therefore, 1 plus X is equal to 0. Therefore, X is equal to minus 1. Therefore, the oxidation number of cobalt here is minus 1, which is option B. In NiCl4 2 minus, the number of unpaired electron is A 4.5, B 2, C 3, and D 4. Now let's look at the answer. Now NiCl4. Here the oxidation number of Ni is given as plus 2. Therefore, Ni plus 2 has an inner orbital pair energy of D8, which is given by, and S is, so here two electrons are unpaired for nickel. Now, therefore, if in NiCl4 also the number of unpaired electrons will be 2. This is the structure of NiCl4. Therefore, here also the unpaired electrons will be 2. Therefore, the correct answer is option B, 2. Coordination and oxidation number of X in the compound XSO4 NH35Cl will be 6 and 4, 10 and 3, 2 and 6, and 6 and 3. Now here the oxidation number is 6. Now to find the oxidation state, we need to assume that the oxidation number of X is actually small x. Therefore, XSO4 NH35 Cl minus. Therefore, oxidation number of SO4 will be minus 2, NH3 will be 0, and Cl will be minus 1. Therefore, X minus 2 minus 1 is equal to 0. Therefore, the oxidation number of capital X will be equal to plus 3. Therefore, the correct answer is option D, 6 and 3. The diamagnetic species is NiCN4, NiCl4, COCl4, or COF6. Now, let's look at this. First option, NiCN4 2 minus. Now in all the four options, sp3 is empty, so they will have d energy atoms. Therefore in this, here all the electrons are actually paired with the exception of the last. Therefore this is diamagnetic. Now in the second option, option B, if you look at option B's hybridization, here there are two electrons which are unpaired. Therefore this is paramagnetic because of unpaired electrons. Option C, also there are three electrons that are unpaired. Therefore this is also paramagnetic. And in option D also there are three electrons which are unpaired, which is also paramagnetic. Therefore the correct answer is option A. Which one of the following complexes is paramagnetic? A. COF6 3 plus, B. COH2O6 3 plus, C. COF3 H2O3, and D. All of these. Now if you look at COF6 F6, here only two electrons are paired, rather than the rest of the three electrons are unpaired. Therefore this is also this is paramagnetic. Similarly, if you look at B and C also, as the ligands are weak, they do not induce pairing of electrons, so they all show paramagnetism. Therefore the correct answer is option D, para all of these. Isomers are possible in COEN2, Cl2 plus, A2, D4, C6 or D1. Now, the compound COEN2, Cl2 has two geometric isomers and two optical isomers. So, the cis isomer, which is given by this is the cis isomer, and the trans isomer is given by actually a rhombus shape. So this is a trans isomer. Again, cis isomer can give two optical isomers, which can be shown as another cis isomer and a trans isomer. Therefore, four types of isomers are possible for COEN2 Cl2. Therefore, the correct answer is option B. Complex PTNH36Cl4 furnishes into 5 ions, 4 ions, 3 ions, or 2 ions. Now let's look at what happens when PTNH36Cl4 furnishes. It furnishes to give PTNH3 6 4 plus 4 Cl minus ions. Therefore in all it gives 5 ions. Therefore here the correct answer will be option A, 5 ions. Is are the numbers of unpaired electrons in the square planar PtCN4 2 minus ion? A0, D1, C4 or D6. Now the outer electronic configuration of Pt is 5d9 6s1, and the electronic outer configuration of Pt2 plus is 5d8. Now since here it is Pt2 plus, therefore its electronic configuration is 5d8. Now as Cn is a strong field ligand, so pairing will take place. Therefore Pt2 plus will have the following pairs. All the electrons will be paired except for one which will be empty, and it has this hybridization. Therefore all electrons are paired and there are zero unpaired electrons. So the correct answer is option A. Hybridization in CO and H36 3 plus is A sp3, B sp3d, C d2sp3 or D sp3d3. Now the valency shell electronic configuration of CO2 plus is 3s, 3p and 3d, where 3 electrons are unpaired. Now therefore the formation of CO, in the formation of CO and H36 2 plus complex, it undergoes complex hybridization and forms It forms a diamagnetic structure where all the electrons are paired except 2 in D2, 1 in S, and in P. Therefore, it forms a hybridization of D2sp3. Therefore, the correct answer is option C, D2sp3. H2 as a weak field ligand, the number of unpaired electrons in MnH2O6 2 plus will be atomic number of Mn is 25, A2, B4, C3 and D5. Now, Mn25 atomic number has an hybridization of 3D5 4s2. Now, considering that H2O is a weak field ligand, there will be no pairing of electrons. Therefore, it will form a higher spin complex. Therefore, Mn2 plus will form 3D5, which will be no electron will be paired. That is, the number of unpaired electrons will be equal to 5. The correct answer here is option D. Hybridization of Fe in K3Fe CN6 is A sp3 dsp3, C sp3d2 and D d2sp3. Now K3Fe CN6 electronic configuration of Fe is 4s2 3d6. Electronic configuration of Fe3 plus is equal to 3d5. Therefore, it will form electronic configuration like this. Now, since the nature of the ligand is a strong field, therefore the all the electrons will be paired, and it will form a hybridization like this. And this all will be empty along with P. Therefore, it will form a hybridization of D2sp3. Therefore, the correct answer here will be option D. Among NiCO4, NiCN42- and NiCl42- species, the hybridization states at the Ni atom are respectively. Here are the options. Now, in NiCO4, the hybridization will be all the electrons, all the electron paired will be paired. Therefore, and this will S and P orbitals will be empty. Therefore, it will be sp3. In NiCN42-, all the electrons will be paired in the d orbitals, leaving one. Therefore, this will be paired, this will be paired, this will be paired, and this will be paired. And S and P3 will be unpaired. Therefore, their configuration will be dsp3. And in Ni, since here there is a strong field, there is a weak field ligand, all the electrons will be not paired except the first and the second electrons. The three electrons won't be paired. However, there will be no electrons in the s and the p3 orbitals, and therefore the hybridization states will be sp3. Therefore, the hybridization state will be sp3, dsp3 and sp3 respectively, which therefore the correct answer here will be option D. Number of d electrons in CrH2O4 3 plus is A2, B3, C4 and D5. Now chromium 3 plus has an atomic number of 24 and will have an electronic configuration of 4s0 and 3d3, which will be paired as S and D. Therefore, the number of the electrons will be 3. The correct answer here is option B. The following compounds is colored: A TiCl3, B FeCl3, C COCl2, or D all of these. Now the compounds having metal ions with unpaired electrons are colored. Therefore, in TiCl3, metal ion is Ti plus and has an electronic configuration of 3d1. Therefore, one unpaired electron. Therefore, this is colored. In FeCl3, Fe3 plus has an electronic configuration of 3d5, therefore have 5 unpaired electrons. Therefore, this is also colored. And in COCl2, CO2 plus has an electronic configuration of 3d7 and has 3 unpaired electrons. Therefore, this is also colored. All three of the compounds are colored. The correct answer here is therefore option D. Of FeCN6 4- ion is A hexagonal, B pyramidal, C octahedral, or D octagonal. Now Fe2 plus has a hybridization state of given by there will be 4 unpaired electrons, which has a 3d, 4s, and 4p. Now, in the presence of Cn, it has the electrons will be paired since Cn is a strong field ligand. Therefore, the electrons will be paired and will have all the unpaired electrons right here, and therefore it will have a hybridization of D2sp3, which has an octahedral geometry. The correct answer here is therefore option C, octahedral. Octahedral complex, which is given here, is either A cis, B trans, C mer, or D fac. Now, when three ligands with the same boron atoms are on the same side, same triangular face of the octahedron, the isomerism is called as facial or fac isomer. Now, in this complex, which can be drawn like this, B, A, and there is another one here. Three ligands are on the same side of the triangular face of the octahedron. Therefore, the correct answer here is D, fac. What is the magnetic moment of K3FeF6? Here are the different options. Now, in KTF3F6, Fe3 plus has a hybridization of 3d5 and 4s0. Now, since K3 is a weak field ligand, all the 5 electrons are therefore unpaired. Therefore, the number of unpaired electrons is 5. Now, the magnetic moment is given by the formula root of n into n plus 2, where n is the number of unpaired electrons. Therefore, 5 into 5 plus 2. And therefore, the magnetic moment is 5.91 bm. The correct answer here is therefore option A, 5.91. How many unpaired electrons are present in the central metal ion of COCl4 2 minus A3, B4, C5, or D2? Now, CO, which has a atomic number of 27, has the hybridization of 3d7 4s2. Therefore, since CO is a strong field ligand, it will have a hybridization of, here all the electrons will be paired except the last 3. Therefore, the number of electrons will be equal, unpaired electrons will be equal to 3. The correct answer here is therefore option A. The number of precipitable halide ions in the sample PTNH3Cl2BrCl will be A2, B3, C4, and D1. Now, PTNH3Cl2BrCl, if it precipitates, gives PTNH3Cl2Br plus Cl minus. Therefore, the halide ion Cl minus is precipitable and it is only 1. Therefore, one ion is precipitable. The correct answer is option D, 1. So the following complex will show geometrical as well as optical isomerism. Here are the different options where En means ethyl diamine. Now, if you look at option D, PTEN ethyl diamine, Cl2, it shows geometrical isomerism like this. PT in the middle, with Cl above, and it shows this is the cis and the trans is with Cl here and Cl here. Therefore, this shows geometrical isomerism, and therefore this also shows optical isomerism, in which optical isomerism is shown as PT here, yeah. Therefore, this is cis and trans can be drawn by changing the side of En on this side and this side. So we can show both type of isomerisms. Therefore, C is the correct answer, which shows both geometrical as well as optical isomerism. Movement spin only of NiCl42 minus is, here are the options. Now, in the paramagnetic and tetrahedral complex NiCl4 2 minus, Nickel is in the +2 oxidation state, and the iron has the electronic configuration of 3d8, which is given by, so the number of unpaired electrons will be 2, and these are the s and the p orbitals. Therefore the number of unpaired electrons will be 2. Magnetic moment is given by root of n into n plus 2, where n is the number of unpaired electrons. Therefore substitute the values 2 plus 2 plus 2, which gives 2.82 bm. The correct answer here is therefore option C, 2.82. The type of magnetism exhibited by MnH2O6 2 plus ion is A. Paramagnetism, D. Diamagnetism, C. Both A and B, and D. None of these. Now Mn2 plus has a hybridization of 3D7 and 4s0. Now since in the presence of H2O, which is a weak field ligand, no pairing of electrons, which results in unpaired of electron left in the compound. Now since H2O is a weak field ligand, there will be no pairing of electrons, and therefore the electrons will be 1 1 1. There will be 3 electrons which will be unpaired. Therefore this shows paramagnetism. The correct answer here is therefore option A, paramagnetism. Complexes CONH36, CrC2O43, CrNH36, and COC2O43 will have which type of isomerism? A. Linkage isomerism, B. Geometrical isomerism, C. Coordination isomerism, and D. Ionization isomerism. Now this will have coordination isomerism, because coordination isomerism is possible when both positive and negative ions of a salt are complex ions, and the two isomers differ in the distribution of ligands in the cation and anion, which is happening in all the four complexes. Therefore they show coordination isomerism, which is the correct answer, which is option C. The possible number of optical isomers in COEN2 Cl22 plus are A2, B3, C4, and D6. Now this compound has a D-cis isomer and an I-cis isomer like this. So CO will be in between. There will be EN here, EN here, and Cl and Cl. This is a D-cis form, and we get an I-cis form by interchanging the positions of En on this side like this. So En will be on this side, there will be Cl. Therefore there is another isomer which is possible, which is trans meso form, which is basically a rectangular with both the En atoms on the opposite sides, with Cl above and below. Therefore three types of isomers are possible. The correct answer here is therefore option B. The number of geometric isomers for PTNH32Cl2 is A2, B1, C3, and D4. Now the cis isomer for this will be PT. There will be Cl here, NH3 and NH3, and it will also have a transform with PT with Cl here, Cl on opposite sides and NH3 on opposite sides. So these are the two geometrical isomers which are possible for this. Therefore the correct answer here will be option A, 2. CuNH34Cl2 plus exhibits A. Geometrical isomerism, B. Optical isomerism, C. Bonding isomerism, or D. Ionization isomerism. Now CuNH34Cl2 plus is the Ma4B2 and Ma2B3 type complex. Therefore it exhibits cis and trans isomerisms, which is like this. So A will be here, B, B, A, A. This is the cis. And we obtain the trans isomerisms by removing A from here and putting B here. Therefore, this is how we get the cis and trans isomerisms. And therefore, they show geometrical isomerisms, which is option A. NiCO4, NiCN42 minus, and NiCl42 minus. These are the options which state some are diamagnetism and some are paramagnetism. We need to find the correct answer. Therefore, now let's look at all the solutions. Now, Ni in NiCN4 2 minus is, since there are no unpaired electrons, since all the electrons are paired and there are no unpaired electrons, it shows diamagnetism. Therefore, NiCN4 2 minus is diamagnetic. Now, NiCl4 has 3 unpaired electrons. Therefore, there has 2 unpaired electrons. Therefore, this shows paramagnetism. And NiCO4 does not has any unpaired electrons. All the electrons are paired in their d orbital. Therefore, this shows diamagnetism. Therefore, the correct answer is option C. NiCO4 and NiCN are diamagnetic and NiCl4 is paramagnetic, which is option C. CONH35NO2Cl2 and CONH35ONOCl2 are related to each other as here are the options. Now, let's look at the diagram of both these things. Now, CO ONO NH3 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 NH3. This is the second compound. And the first compound is given by CO NH3 NO2 NH3 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 and NH3. Here more than one atom function as donor, as oxygen in first one, as oxygen in first, which is here, and nitrogen in the second. So they show linkage isomerisms. Therefore, the correct answer is option C, linkage isomerism.